Hello, in this video I will demonstrate how to install EKS cluster and configure it with Karpenter Autoscaler version 1. Karpenter API has been upgraded from V1 beta to V1 recently. With the upgrade there comes some minor changes to the API specification, and in this demo I will be using the AWS Bottlerocket for EKS cluster as well as for Karpenter provisioning. Bottlerocket AMIs are optimized for container workload, and it has a much smaller size, and in terms of spinning up the new nodes it will be much faster than the Amazon Linux. So I'll be using Terraform for installing EKS cluster, and I'm using Terraform module. All the code is available in my Git repo, and you can follow this instruction. So to start with, I'm installing the EKS cluster. There are a couple of things you need to be aware of when you're creating the EKS cluster. Number one, for the VPC, you need to have a tag for your subnet. So when you're creating a VPC, you need to make sure you assign a tag. In this case, I'm using the tag for karpenter/.sh/discovery and putting the EKS demo. That's the name of the cluster I'm using. You also need to specify a tag for the security group that Karpenter should be using when it is provisioning a new node. So I'm adding a tag for node security group. I've already created the EKS cluster and it's ready to go. And as you can see, I'm using an Amazon Bottlerocket AMI for creating the EKS cluster itself. I'm using the authentication mode of API only, and also enabling the cluster creator admin permissions. So whoever create the cluster will have the admin permission on the EKS cluster. So the Karpenter application requires some IAM policies and permissions. So here I'm creating a IAM policy for assume role. I'm installing Karpenter in the Karpenter namespace, and I will be creating a service account called Karpenter controller. So I'm creating a policy for allowing Karpenter to assume this role. And I'm creating a role and adding a couple of permissions. One of the important one I'm adding extra here is EKS describe cluster. So if you add this one, we don't need to specify the cluster endpoint in the Karpenter configuration. Karpenter can describe the cluster and get the cluster endpoint. So this makes it much more easier to make the configuration dynamic. You also need to create a EC2 instance profile. It is not required, but again, I like to create a separate instance profile. And so I have defined the instance profile. I have already created this, so we are ready to go. So I will update my kube config. I can check the connection and I'm able to connect to the cluster. In this Karpenter app folder, I created a values file for the Karpenter. And here we have to pass the value of cluster name. Number of replicas, I'm only having one because I'm only spinning up single node. And service account, I'm specifying the service account. This is the same name I specified when I'm creating the IAM role. And also you must create the annotation for the IAM RSA to specify which Karpenter role to assume. Again, this is the Karpenter role we created in the IAM role. So if you go to the Karpenter installation, I'm using Helm installation, and I'm using 1.0.6. This is the latest available version at the moment, and also I'm using the Karpenter values which are specified here. So in the terminal, you can see I'm using K9s. You can see already there are 3 ports running, which is EKS cluster with nothing extra running. I'm already in the folder, and I'm installing the Helm installation unexpected. So if you're getting this error, that means you're not authenticated to ECR, so you can use this command to authenticate. Login succeeded, so now I'm ready to install the Karpenter. So I'll go ahead and install it. So Helm chart is installing the Karpenter, and you should see the Karpenter port coming up. You can see the container is creating and it's up and running. So if you check the logs, it's all info, there's no errors, so the Karpenter seems to be up and running. So the next step is to configure the Karpenter node pool and EC2 node class. So here's the configuration for the node pool, and as you can see, we are using the V1 version, and configuration is standard. I'm using a architecture AMD 64. Karpenter can also spin up ARM servers, and I'm using Linux as operating system, and I'm making use of spot instances as well as on demand. So it will be a good idea to use spot instances to save cost. And instance type, you can specify what type of instances you need to allow. I'm also defining minimum number of CPU should be 2. So that's not spinning a single node with single CPU. There's slight difference in here in the node class reference compared to the beta version, and the definition is changed. And also there is slight difference in the disruption section compared to the V1. Sorry, compared to the beta version. Again, we go into creation of the EC2 node class. Here I'm using again V1, and there is some slight difference in the AMI specification. In my case, I'm using a Bottlerocket AMI, and you have additional parameters called AMI selector. Here I'm able to select the latest Bottlerocket AMI. In general, I find the Bottlerocket is much faster to spin up a new node, and we will have a comparison of against the Amazon Linux later on. If you like to enable the Amazon Linux, obviously you got this option you can enable instead of Bottlerocket. In the subnet selectors, we are specifying the subnet tag. This we already created when we are creating the VPC. And also security group, which security group to assign to the nodes provisioned by the Karpenter. This we defined when we created the EKS cluster. So our Karpenter pod is ready. Now we are ready to apply the configuration for creating the node pool and EC2 node class. So we'll go ahead and apply. And also we'll also check the logs on the Karpenters, make sure there's no errors. Okay, no errors been reported. Let's have a look at the node pool. Node pool is ready. Okay, and EC2 node class. So if you look at the EC2 node class is ready. So that means we are ready to test the application. So I provided a sample app here, so you can always deploy the sample application. This is a very simple application with 4 replicas and requesting CPU of half CPU. So number of replicas should trigger auto scaling by default. So let's have a look. And here you can see there's no application and there's only a single node. So we're going to apply the applications and spinning up a couple of containers, and at least one of them is in pending state. So if you look at the status of that, you will see it is pending because insufficient CPU. So that should trigger something in the Karpenter. So let's look at the Karpenter logs. So here you can see already Karpenter detected there's a need for a new node and it's already provisioning a new node. So, and you can see already it's provisioned a new node and it's getting ready. And it's in a ready state within 15 seconds. 15 seconds is ready and the application content is getting created. Let's delete this application. And within a minute, you will find the Karpenter will remove the nodes. Okay. As you can see, the application is removed and Karpenter also removed the node. Okay, let's have a comparison of running Amazon Linux instead of Bottlerocket. I'm going to remove the Karpenter node pool and EC2 node class. And in the code, I will go ahead and update to run the instead of Bottlerocket, I'll be running the Amazon Linux 2023. So I'll comment out the Bottlerocket in the node class. Okay, I'm applying the configuration again, and this time we are configuring Karpenter to spin up Amazon Linux node pools. Okay, it's been created, and if you go ahead and check the node pool, you can see node pool is ready. So let's apply the same application and see how long it takes for the Amazon Linux to come up. So applying the same configuration for number of ports, and here again you can see one pending node, and obviously if you look at the Karpenter logs, yep, Karpenter already identified, and you have the node is coming up. You can see the new nodes being spun up, and let's see how long it takes. Okay, Amazon Linux 2023 is taking similar amount of time to Bottlerocket. That's good. If you are looking to remove the Karpenter and reinstall, these are the steps you need to follow. First of all, you need to make sure there's no nodes provisioned by Karpenter, and then go to the node pool. Okay, you need to get rid of the node pool, and then into EC2 node class, remove the node class. So uninstall Karpenter applications. So make sure Karpenter is uninstalled. Once the application is removed, you have to go and remove the CRDs. Because when you're uninstalling the application using Helm, it does not remove the CRDs. So you can see there are CRDs installed, and I'm removing the CRDs manually from the server. Okay. There you go. The Karpenter is removed. completely. Now you are able to install the Karpenter V1 as a fresh installation. Thank you. Hope you find this information useful.